Building a Dyson sphere around the sun and harvesting all its energy is a distant dream for many. However, according to the Kardashev scale, a developed one-star civilization could successfully build such a large star structure. According to recent assessments, we are as close to achieving this goal as hunter-gatherers were to building. Nuclear power plants are just as far away. In order to narrow this gap, scientists propose various extraordinary projects. For example, placing millions of diamond balls on the Earth, launching a giant hexagonal ship into orbit, or let half the population live underwater. But can humans really reach this level? Or is this beyond our capabilities? In order to improve the level of our civilization, we must accelerate technological progress to dangerous speeds. In 1964, Soviet scientist Nikolai Kardashev developed a special scale. He believes that all intelligent civilizations should develop according to this scale. The level of civilizational progress depends on the energy consumed and generated by the civilization. The original Kardashev scale had only 3 levels: Type 1 planetary civilization, Type 2 stellar civilization, and Type 3 galactic civilization. Therefore, if we want to become a Type 1 civilization, we must produce all the energy possible on Earth, including planetary resources and access to solar energy. According to Kada consumption standard, our current level of development is approximately 0.75 G. This agreement is very close. However, the problem is not linear at this scale, but logarithmic. This means that the closer to the end, the more energy is needed to move forward and achieve at least 1 unit. Therefore, it is calculated as 7,500 seconds. We actually only have, of all the energy generated by the low-star civilized Eagle, only 2 out of 10. To improve on this scale by only 1%, we need to start producing 25% more energy than we do now. So how do you get such a powerful energy boost? Lawrence recently, a team of researchers from Livermore National Laboratory and the Japan Aerospace Exploration Agency came up with a pretty interesting solution. This project is called Copia, including some giant hexagonal mirrors. They are in space, reflecting and redirecting solar energy onto satellites. These satellites then convert this into radio waves and transmit them to Earth. What's called a rectina there turns it into electricity. Scientists say even one such device could completely replace several of Earth's nuclear power plants. However, the most exciting part is, according to the project CEO Martin Sudo, the amount of energy generated this way can be almost unlimited, because for those mirrors placed in specific orbits, the sun never sets. The final energy output, therefore, depends only on the number of such devices. So far, this project is purely theoretical, but governments in leading countries are prepared to allocate more than $10 billion to implement it. However, not only does each new similar megaproject bring us closer to a hyposexual civilization, it also puts us at risk of complete extinction. And the reason for this is the big filter. The term was first coined by scientist Robin Hansen in 1996. In his view, the faster a particular life form evolves, it may become more dangerous. Although humans seem to have existed for eternity, but in fact, on the time scale of the universe, the formation of human beings, especially basic development, evolved extremely rapidly. After all, the universe is more than 13.2 billion years old. Intelligent humans only appeared 300,000 years ago. On a cosmic scale, this is almost the same thing. We are evolving faster than ever. So we face an insurmountable obstacle. This will not lead us to a Kardashev-scale low-level civilization, but towards the end of tragedy. This is what it means to be greater than green energy. Today we are surrounded by many potential disasters, from the uncontrollable greenhouse effect to the dangers of extreme artificial intelligence development. But what does this have to do with space mirrors? Dr. Jovana Radulovic, professor of thermodynamics at Portsmouth University, calculated the carbon footprint of launching the Copia project would be 100 times greater than all our industry and transportation emissions. To get clean solar energy from space, we risk further damaging the planet. risks to damaged ecosystems. Does this mean, on our path to Type 1 civilization, we should not rely too much on a new superstar project that could have unintended consequences? Maybe we should continue to using the energy we are used to today. About 70% of the Earth's current energy needs still rely on coal, oil, and natural gas to meet the needs of. The problem with natural resources is not only they emit chemicals and carbon dioxide into the atmosphere, and they are running out. What's more important, according to the latest research, the rate at which this resource is consumed, much sooner than we first thought. Experts from the Slovenian Institute of Geodesy calculated, if we maintain the current production rate, Earth's coal reserves will only last another 133 years, and oil and gas resources will be exhausted within 50 years. Even if we are just trying to increase energy production from traditional energy sources, this will also bring us closer to a civilization that is not hyposexual, but the collapse of civilization. So the old energy sources can no longer be used. But we haven't found enough alternatives yet. What's more serious is, a 2015 study published in Science Advances research in the journal shows, such extreme measures would truly lead to a major flood. If we burned all the remaining fossil fuels on Earth, Antarctica's ice will almost completely melt. Global sea levels will rise by up to 60 meters, submerged half of Europe, and even all island countries and most coastal cities in the world. This will result in hundreds of millions of people becoming victims. Despite this, now we not only have natural resources and nuclear energy. Today it helps produce about 15% of the world's electricity. The solution seems obvious. We just need more nuclear power plants, however. After the disasters of Chernobyl and Fukushima, many advanced countries, such as Italy, Germany, and Belgium, shut down their nuclear energy projects. Even with the development of new technologies every year, such disasters are becoming less and less likely. This type of energy, there are still many serious problems. Nuclear energy is now a ticking time bomb. We have almost no way to dispose of radioactive waste. They can only be stored in the hope that future scientists will figure out a solution in the next 1,000 years. Furthermore, even if we occupy all available sites to build nuclear power plants, this only brings us 1/10 of the way forward on the Calda negative elimination scale. To move forward a little bit, we're going to need to build nuclear power plants everywhere. Another alternative could be another type of atomic energy, thermonuclear fusion that converts hydrogen into helium. This releases more energy. The nuclear fusion device has an amplitude of 138 megaelectrons. Modern nuclear reactors only have a pitiful 1.72 trillion electrons. At the same time, nuclear fusion produces almost no toxic waste. Inspired by this, Troy Carter, a physicist at the University of California, developed a system able to completely transition the United States to fusion energy. Such a reactor is 10 or even 20 times smaller than a traditional nuclear reactor. The energy generated at the same time is as much as 8 times. If you laid out a network of interconnected fusion reactors across the country, most industries will no longer require additional electricity. But unfortunately, this project is not yet possible. After all, every fusion reactor built to date, it consumes more energy to start itself than it produces. Experts from the Livermore Laboratory said at a press conference in December 2022, they use powerful laser equipment, successfully obtained approximately 3 times more energy than that used to initiate a thermonuclear reaction. In fact, if you not only calculate the energy within the reactor, also calculates the total energy required to run the laser machine, you'll find that the pure energy released is 1,000 times less than the energy consumed by the entire United States. Meanwhile, the reaction itself only loses a batch of seconds. Scientists often don't have time to capture the energy released. Even if we use the best technology available today to build a network of thermonuclear fusion reactors, there is not enough electricity in the world to start it. So should we in other technologies, looking for the key to improving Calda's consumption standards? Today we use alternative energy. produces approximately 11% of the world's electricity. Among them, hydropower is the leader, accounting for 7%. However, this is clearly not enough to meet all the needs of the Earth, let alone surpass them. Even if we manage to start up 5 times the current number of hydropower stations, enclosed generator and solar panels, our progress on the Calda consumption scale has been almost negligible. The results show the only way out is to continuously improve existing technologies and squeeze the maximum benefits from them. One way is to extract energy from the moon instead of the sun. Of course, this doesn't mean the faint light from our satellites. Rather, its gravity causes powerful ocean tides on the Earth every day, and the energy of these tides is actually wasted. In order to collect it, we need to build fancy power stations like this near the coast, equipped with lightweight underwater propellers. Whenever water moves towards or away from the coast, they will turn. Scientists say the power of such a power station can reach 300 megawatts. If one could build such power stations on all available coasts, we will immediately advance about 1/10 on the Kardashev scale. Although this is not enough. But if we're not just connecting underwater energy here, and what about underground energy? Large amounts of heat are constantly migrating from the Earth's core to the surface. With so much geothermal energy, you could heat up to 750 million homes. To start taking advantage of this resource, we need to drill wells at least 2 kilometers deep in suitable places, then use hot steam to heat the water. It can also be turned by a special turbine and generate electricity. Perhaps with this, we will be able to accumulate enough energy to start thermonuclear fusion, and the ocean could provide it with an almost endless source of fuel. They contain enough hydrogen to convert matter into energy. With such reserves, we will be able to, without any additional energy, producing electricity for millennia. If you put a cataclysmic battleship in the ocean, they may even be easier to launch. Because of tidal energy, scientists just need to figure out how to accumulate large amounts of energy in a very short time. If such technology can be developed in the near future, we will be able to get significantly closer to the status of a Type 1 civilization, harnessing the energy of the ocean and the Earth itself. But how do we fill that final gap? 1973. American astronomer Carl Schon developed Kardashev's ideas. He reasoned, Type 1 planetary civilization will be able to control any natural phenomenon. Tsunami, tornadoes, and earthquakes will become an additional energy reservoir. Humans may soon be close to this kind of power. Back in 2010, scientist John Stoschel proposes concept of a weather machine. It is a set of tiny transparent spheres. Sizes vary from 1 millimeter to 1 centimeter. Each sphere is made of the thinnest diamond shell. Thickness should not exceed 1 nanometer. Inside they have a membrane and a microcontrol unit. Helps tilt the unit in different directions. Millions of hydrogen-filled spheres surround the Earth in the stratosphere, about 30 kilometers above the sky. Remote control can shade drought-prone areas, simultaneously reflects and redirects light to areas lacking light. Excess solar energy can be converted into unlimited radio waves and sent to the Earth. So not only will we significantly increase the generation of electricity, we'll also significantly optimize its costs. Unfortunately, John Hall's ideas were not widely accepted in the scientific community. Experts say these ideas are too unrealistic. Recently, however, researcher Robert Fries revisited the concept of weather machines and concluded that it is actually feasible. The first small-scale model testing is planned for as early as 2032. Still, skeptics warn, this manipulation of the atmosphere could lead to unexpected climate changes. It could even lead to an ice age. Of course, we want to avoid such large air filters. In order to become not only a hyposexual civilization on the scale of Kardashev and maintain this level, we need some fundamentally new approaches. How to extract energy from things we usually don't pay much attention to. 2019. A group of Filipino graduate students came up with an unusual device, able to generate energy from urban noise. It turns out, An average metropolis can generate up to 11,200 megawatts of energy from its sound, just like an ordinary thermal power station. And noise pollution can power neighborhoods. Ordinary trash can power an entire country. Plastic production increases by millions of tons per year, but only 1/10 of the amount can be subsequently reused. If we try to extract energy from garbage, rather than recycling it, unfortunately, the most obvious solution, simply burning plastic for heat, fails. In fact, greenhouse gases produced in this case 4 times more than the rest of the entire energy industry combined. By burning garbage, we will bring in big filters faster than uncontrolled energy production. Humanity has a chance to resurface from the sea of garbage, opening up a new future of pure energy. Pyrolysis is a process that controls the decomposition of chemical compounds. Previously, it was thought that on an industrial scale, it could only be applied to organic matter. But in recent years, it has been successfully used to break down plastics. In a pyrolysis machine, plastic is decomposed by heat in a vacuum without emitting smoke. The resulting chemicals are burned and used as feedstock for fuel and other products. So far, such devices are only used in certain industries. But in 2021, Italian scientist Sabino Alan and his team proposed a concept, making plastic pyrolysis a truly global technology. If one adds to all previous innovations, it can also recycle all the garbage floating in the ocean. We will quickly reach the level of Type 1 civilization. In addition, in the evolved waters, future energy-independent cities can be built. This is a must for any Type 1 civilization. Japan's Shimizu Corporation's Ocean Spiral project, designed to accommodate thousands of residents without significant energy costs. This floating sphere with a diameter of 500 meters is located below the sea surface. Will contain commercial and residential areas, hotels, gyms, gardens, and cinemas. Basically, everything a human needs to live comfortably. The capsule will be connected to the seafloor via a 15 kilometers spiral path. For such a big city, does not require any additional energy source. After all, the seabed is closer to the riverside. If you only drill a well 1.5 kilometers deep, the Earth's heat alone can fully meet all energy needs. Maybe you don't even need charcoal. If humans master another energy source that is several orders of magnitude more powerful than thermal fusion, it is an ordinary substance with all parameters reversed. The most important thing is, when corresponding particles collide, matter and antimatter will annihilate each other in powerful flashes of light. The energy released here is approximately 250 billion times the fusion energy. Imagine, just one particle of antimatter can generate more than 52,000 megawatts of energy, enough to supply 40 million households. But there is a problem. That's antimatter, which is almost impossible to live on Earth. This is why engineers haven't even considered building an antimatter power plant, until scientist James Bickerford came up with the idea of mining him in space. To do this, we need to launch 2 high-temperature superconducting coils beyond Earth orbit. These coils will be powered by solar energy to create a magnetic field. To capture antimatter, theoretically in just one day, humanity can obtain 20 times the current production capacity. But antimatter hides a danger. This could become another huge obstacle on our path to becoming a heterosexual civilization. American physicist Robert Forward believes that matter and antimatter should be proportionally balanced in the universe. If you extracted a lot of antimatter from space, this balance will be destroyed. Scientists recently discovered that the Earth's magnetic field has attracted some antimatter particles. If you start mining antimatter near Earth, this may affect its magnetic field operation until it completely disappears. Then the charged particles in the solar wind will hit every electronic device on our planet. These devices will soon become irrelevant, because there is no protection from the magnetic field. Mobile communications and the internet will also disappear on Earth, plus a painful death from radiation sickness. This is the climax of disaster. And our civilization is not a star on the Kardashev scale, but will go backwards and fall. Scientists believe it's not just technical difficulties or technical problems that are holding us back from achieving dramatic energy breakthroughs. Potentially huge filter. We have clearly seen that. To become a one-star civilization is impossible without certain large-scale projects. But in today's world, only authoritarian societies can implement such a project, like the record-breaking skyscrapers and man-made islands in the United Arab Emirates. Unlike democracies, where citizens are not asked specifically what they should spend their money on, Carl Schon firmly believes that human beings can only live under absolutely equal human rights and democracy, only in order to become a prosperous heterosexual civilization and maintain this status. But how many people would actually vote to put their entire year's budget, flowers on the six-pointed star mirror, or going without electricity for several days in order to run a massive network? So far, it has been difficult to find a solution to this paradox. So what do you think about how to organize human beings to achieve heterosexual civilization? And do you have any suggestions for realizing your Dyson ball dream?